You've probably noticed a massive gap in how different AI systems behave. Talk to a standard chatbot, and it forgets what you said, but interact with an advanced AI assistant, and it seamlessly picks up where you left off last week, recalling your specific preferences and past projects. That gap comes down to two specific engineering concepts: memory and state. Without them, even the largest language models are amnesic pattern matchers. They process language beautifully, but they live entirely in the present moment, unable to accumulate any experience. To move past amnesia, developers build AI agents. An agent is a system that operates in three distinct phases. It perceives its environment through inputs, processes those inputs to maintain an internal representation of the world, and then takes specific actions to achieve a goal. In this setup, the language model itself is really just the reasoning core. To do complex, autonomous work, that core must be wrapped in a larger ecosystem, containing a workflow orchestrator, access to external tools, and dedicated memory subsystems to store what it learns. In AI design, memory is defined as the specific collection of mechanisms that store information from past interactions or external data sources, making it available for future computation. Practically, this means creating an archive. It holds raw conversational history, retrieved documents, and learned parameters, and structured knowledge stores detailing exactly how a user prefers to work. If memory is the archive, state is the present moment. State is the complete set of information at any particular given second that influences how an agent behaves. It represents a strict snapshot in time, dividing into two distinct sets of data. First, there are internal variables, which cover the agent's current working memory, active goals, and partial plans. Second, there is the external context, which accounts for the user's specific session data and the immediate environment surrounding the current interaction. Memory builds the long-term archive, while state anchors the AI firmly in the present task. Combining them is the only way to cure AI amnesia. Most basic AI APIs operate entirely without state. In a stateless architecture, the system processes every single incoming request independently. Because the server doesn't remember prior prompts, the slate is wiped clean after every interaction. The only way the model knows what happened is if the client manually repopulates the context window by uploading the entire conversational payload over and over again. A stateful AI agent flips this architecture. It introduces explicit state management, persisting relevant information automatically across multiple interactions. By managing databases, caches, and memory retrieval services in the background, a stateful system can accumulate experience. It can remember user preferences over months, adapt to new rules, and track its own progress through long-running workflows without needing human intervention at every step. Once a system can retain information, its responses become targeted rather than generic. Memory provides the raw material for contextual understanding, letting the AI adapt its tone and formatting entirely to the user's specific interaction history. It also enables multi-step planning over time. An agent can execute step A, ensure the results are safely filed away in memory, proceed to compute step B, and then retrieve that original data to successfully finish executing step C. But there is a strict mechanical limitation here. An AI does not, and mathematically cannot, look at its entire database at the same time. It has to filter gigabytes of raw storage down to a manageable size. The data that makes it through the selection and summarization mechanisms becomes the active context. This is the highly specific subset of information, measured in individual tokens, that is actively made available to the model for a single decision. The agent's core reasoning operations, its planning, inference, and decision-making, operates exclusively on this active context. It cannot reason over data that is trapped in the database. The information must be pulled into the active prompt window first. Because of this, the quality of an agent's reasoning is strictly bound to its retrieval mechanisms. An AI can only think intelligently about what its memory system successfully surfaces. To manage this flow of data, developers structure agent memory into multiple tiers, starting with short-term memory. In a language model, short-term memory corresponds to the context window. This is the immediate, active workspace, holding the sequence of user messages, prior assistant turns, and recent tool outputs fed into the model for a single completion. While it acts like human working memory, it has a rigid bottleneck. The context window is strictly bounded by model architecture and computing cost. Placing a new document onto a completely full table forces an older piece of information off the edge. Since working memory inevitably hits a capacity wall during any long-running task, an intelligent agent requires a secondary storage layer to handle the overflow, ensuring critical data isn't permanently lost to the void. That overflow layer is long-term memory. This is the persistent storage, like vector databases and relational stores, that survives across sessions, securing massive knowledge bases, historical conversation transcripts, and user profiles. But there is a crucial architectural quirk here. The language model itself is entirely blind to this storage. It cannot peer into the database directly. Instead, the system relies on external retrieval components. When the model needs a fact, the orchestrator queries the database. Search algorithms locate the right file on the shelves, and the system injects the selected results directly into the short-term context window. What we call an AI agent is an entire ecosystem working in concert. It is an orchestrator managing state, interacting with tools, querying a tiered memory system, and feeding highly specific context into a language model core. The transition from an amnesic pattern matcher to a continuous intelligent agent depends on a shift in design. Raw reasoning power is not the bottleneck. True agency is built on treating memory as a dynamic, engineered filing system.